I've got a function of 3 variables up on the board here. So w is our output variable. That's a function of x, y, and z. X squared yz plus sine of xz squared. Okay. And in a moment, I'm going to have you pause the video and find the 3 partial derivatives that we can with respect to x, y, and z. And I've just reminded you here of the alternate forms of notation that we can use for that. Before you do that, though, I do want to just point out that we do still have a geometric interpretation of what's going on here. Now, difficult for us to visualize, at least for most of us, to visualize what the graph of this looks like in 4 space. But when I'm taking a partial derivative, for example, when I take the partial with respect to x, I'm saying x is my only input variable. I'm holding y and z constant. So we're essentially looking at a 2-dimensional cross-section of 4 space. If you hold both y and z constant, then you've got x, and w would be your 2 variables, 1 input variable, 1 output variable. So while I have a hard time visualizing all of 4 space, I can certainly visualize a 2-dimensional cross-section or a plane in 4 space. And of course, the function I would get by holding 2 of my 3 variables constant would just become a function of 1 variable that would give me a curve in that cross-sectional plane. Okay. All right, so just so you get some practice with it, go ahead, pause the video now, find me a formula for each of those 3 partials, and then tune back in. Welcome back. Okay, so if I'm finding the partial with respect to x, x is my only variable. So y and z are standing for constants. So if I look at this first term, y times z, that's just a constant. I'm going to still have that constant times the derivative of x squared, which I know is 2x. So I'll have 2x times the constant yz. Okay. Plus, here I do have some x's in here. So it looks like this is going to be a chain rule. Derivative of sine of something is cosine of that thing. And then I've got to multiply by the derivative of the inside part. X is my variable. That z squared is a constant. So I'm just going to get that constant. And I'm going to just write that up front so that it's super obvious it's not being plugged into cosine. Excellent. If I take the partial with respect to y, okay, now I've got to sort of mentally make this change. Y is a variable, x and z are constants. So in this first term, y is my variable, x squared and z are just constants. That's a constant multiple of y. I'm just going to get x squared z. And there aren't any y's in this term. So this is just a constant. Xz squared is a constant. Sine of a constant is just a different constant. Derivative of a constant is 0. So that's my partial with respect to y. All right, and my partial with respect to z. So mental change. Z is a variable. X and y are constants. Okay. So there's z. Oh, it's being multiplied by the constant, x squared times y. Excellent. Plus, there are some z's in this term. So chain rule. We're going to have cosine of xz squared times the derivative of xz squared. X is a constant, and the derivative of z squared with respect to z will be 2z. So that's going to give me a 2xz, and I'll just write that in the front of that term.